Good day, guys. Alright, so in this video, I want to talk about two things: work done and power. And especially for the work done, there's two parts. Number one is the definition of work done, if there is a constant force. And then the second part is the force displacement graph, how we can calculate the work done using the force displacement graph. And then the third part, and then the next part would be power, on average power and instantaneous power. Okay, so let's look at work. Generally, we will use a symbol W, and this W will be defined, or work done will be defined by the dot product of force, constant force, with displacement. So it depends on two things, right? How much force are you giving it, and how much that thing or that body travels. Okay, so force is constant force. So this force doesn't vary with time. And then we have displacement, which is how far the object is displaced because of that force. Okay, so again, let me just say it again. Work done by a constant force is defined by the dot product between that constant force and the displacement of the body that the force is applied to. Okay, so let's look at force displacement graph. So for force displacement graph, we always start with axis, right? For any graphs, we start with axis. And then the next thing you need to do, that you always have to remember, is to label your axis. So the question that we want to answer is, in this particular graph, how can we calculate work done? So let's have a graph, and then let's think about it. When we talk about graphs, we talk about two main things. Number one is the gradient, right? And number two is the area under the graph. Now the gradient is generally defined, or at least you can work it out, that it's going to be y over x. So whatever y variables over x, right? And that's going to be force and over displacement. If you ask yourself, does this represent work done? Your answer will be no, right? So let's look at the second choice that we have, which is area. So this area will be y multiplied by x, right? And if you refer back to the work done, which is just the dot product of fs, which is multiplication by the end of the day, then you can say that, okay, this is force times displacement, right? In the event that the force and the displacement is in the same direction, the area under this graph represents the work done. Okay, all right, so next we want to look at power. As I've mentioned before, two categorization of power is average power and instantaneous power. So for average power, we are talking about over an interval, and this power is defined to be delta W over delta T, where delta is the work done. Okay, so it's the rate of change of work done. Power is generally the rate of change of work done. Okay, so of course we can expand this to include Wf minus Wi over a time interval, which is the final time minus the initial time. All right, now if we were to expand this definition of power, right, P equals to delta W, so I can use delta over delta T F dot S. If we expand that, right, and we know that force is a constant, so we can take it out, delta S over delta T, what we will get is F dot V, velocity. So the dot product of force and the velocity of the body at that particular time, right, gives us instantaneous power. So we didn't talk about intervals. All we talked about is what is the velocity at that point, what is the velocity of the body at that point, and what was the force, what was the magnitude of the force and the direction, right, at that moment in time. So as you can see, we talk about intervals here, intervals, and this is at a instant, which is why there's the difference between average power and instantaneous power. When you talk about instantaneous power, you are asking how much, what is the power at that point in time. When you talk about average power, what was the power throughout some time interval? All right, so that is the end of this video. In the next video, I'll be looking at conservation of energy, and I will be looking at the work energy theorem as well. So this video will be about this video was about definitions, and then the next video will be more on concepts. All right, so that is it. Thank you very much. I'll see you in the next video.